Okay, I love these geometric mean problems because once you get the hang of it, you really find it to be easy breezy. But when you don't have the hang of it, man, it can feel like a stumper. So what I suggest you to do is um, really practice these well. Okay. Um, Now it says we're trying to find the length of the altitude drawn to the hypotenuse, and what you get when you do that, or how you do that, is you take this length times this length, 5 times 16, multiply them together, and then square root them. So we say we're going to take, to find out the altitude, to find out this altitude, and let's call it A for altitude, we can say A is equal to the square root of, sorry about that, the square root of 5 times 16. And when we do that, we say, okay, then A is equal to. Now, as we've been working on these over the last, I don't know, several days, week, I taught you some tricks and some ideas. One trick and idea is that if you can see a perfect square in there, don't even bother multiplying them together. Just square root that and bring it out front. What's the square root of 16? It is 4. Okay? And unfortunately, well, not unfortunately, just it's a fact that 5 is not a perfect square, and there's also no match pair. There's not a second 5 in there. So that's just going to stay in there as a 5, and we get 4 root 5, and that's A. Okay? Now that was, they give you a visual representation of that. These last three, they don't give you a visual representation of it, but that doesn't intimidate you. What's the geometric mean? Remember, to find the geometric mean, you take the square root of the two numbers that they gave you, 4 times 7. And as I said, even though, yes, you could put it together to be the square root of 28, we can just say, well, before we even bother putting them together, let's see if there's any perfect squares. There are. And we'll just bring that out as its square root, 2. 7 is not a perfect square, and it also doesn't have a second 7 in there. So we leave it in, 2 root 7, B. Okay, moving on. 242 and 8. Now, this is actually fun. This one's a fun one for me because I can see something fun that's going on here. When I say fun, I guess that's all relative, right? But here's what I mean by fun. If we say 240 square root of 242 times 8, well, I can start to break this apart. And when I start to break it apart, I break apart 242 to 121 and 2. Of course, the 8 is still there. So 121 times 2 is the 242. But now I know this. Hopefully you know some of this information too. That's a perfect square. 121 is a perfect square of 11. So we can say we're going to bring an 11 out. And what's left? What is left? Well, what's left is a 2 and an 8. And what is 2 times 8? 2 times 8 is 16. What's the square root of 16? 4. So these two together make 16, which when square rooted make 4. So you can bring that 4 out, 11 times 4. And there's nothing left inside because you brought it all out, and the answer is 44. Okay, 44A. Now, if you did this the long way, and you just broke down 242 and 8, and said, what we're trying to do is just find the square root of 242 times 8, and you did a factor tree for all of them, you'd find that for 242, you would get 2 times 11 times 11. Okay? 11 times 11 is 121. 121 times 2 is 242. And then if you broke down the 8, you'd say 8 is just 2 times 2 times 2. And what do we do now? Well, we say that equals, and let's look for pairs. We've got a pair of 2's. That's 1, 2 coming out. We've got another pair of 2's. That's another 2 coming out. We've got a pair of 11's. That's an 11 coming out. And there's nothing left inside. So when you multiply them together, 2 times 2 is 4. 4 times 11, 44. You still get 44 even if you did it the long way. Yeah? And finally, find the geometric mean of 81 and 4. And if we said, okay, geometric mean means to multiply them together and take the square root, then we've got the square root of 81 times 4, and no problem, because 81 is a perfect square of what? 9. 4 is a perfect square of what? 2. When we multiply them together, we get 18. 9 times 2 is 18. So our answer is D.